Hi, Thurul. Welcome to the Software Architecture
Hey,
Conference.
Simon. Thank you very much. Thank you for the invitation. Long time no see.
Yeah, long time no see, but I'm so happy that we get to connect with these live events, right?
Me too. Me too.
Yeah. So you already had your dinner, right? I suppose it is 8 p.m. at your place. So
Yeah,
you,
exactly.
yeah. Okay, Thurul, I know I'm already like 5, 6 minutes in your session, right? We're gonna do a lot of chit chat towards the end of your session. So please feel free to go ahead and share your screen, and then we can get started.
Okay. Thank you. Thank you.
And we both
Let
are
me.
wearing black t-shirts, right? Ooh.
Yeah. Black man for today. Okay, I'm starting.
Okay, I'm waiting for your screen.
Okay. I hope right now
There's something
everyone can
loading
see
up.
my screen. How about
Yeah,
now?
I see your screen. I've added it to the stream. Everybody else can see it, and next 35 minutes is all yours.
Okay, thank you. Thank you, Simon. So, hey everyone, my name is Tural. I'm Microsoft MVP, C Sharp Corner MVP, and Chief Software Architect. I'm author. I have YouTube channel, Tural Suleimani Tech, where I share my knowledge related to C Sharp, SQL, microservices, domain-driven design, GraphQL, all the technologies I know. And today's session is about domain-driven design. I know we have a limited time, so I will try to wrap up and I will try to touch every aspect of domain-driven design, and I will try to explain every building blocks of domain-driven design as simple as possible. Okay. So first things first, before defining domain-driven design, let's try to understand what we have and why, in which type of cases we are able to apply our domain-driven design. So first things first, we need to understand some important key characteristics of software systems. We have performance, we have scalability, we have business logic complexity, we have a big amount of data, and we have technical complexities, like, for example, you have a solution, you have a project, you need to apply complex data structures, algorithms, you need to apply different technologies. This is a technical complexity. So in which type of cases we are able to apply domain-driven design? For example, if you need a performance, if you need a scalability, but you have a simple application, should you apply domain-driven design? Or you have a big amount of data to handle, you have technical complexity, should you apply domain-driven design? Well, we apply domain-driven design when we have business complexity, let's say, okay? Business logic complexity. So also you are able to apply domain-driven design if you don't have any knowledge related to the domain you are working. It means it is not just about you, it is about the team, because the team may not know about the domain. The domain is new. There is no other solution for this domain and nobody knows about this domain. So it is completely okay to apply domain-driven design. And also, if you have an MVP of your application, but you know that in the future there will be a lot of changes, it means you are able to apply domain-driven design. But when not to apply domain-driven design, if you have simple domain, like the CRUD-based application, or also if you have 20, maybe 30, 40 use cases, just defined static use cases. There is no changes maybe in the future or small changes. Domain is really simple. There is no need to apply domain-driven design. This is where we are applying domain-driven design, and under these conditions, we should not apply domain-driven design. And I want to touch on the fact that domain-driven design is not a design pattern. We should understand this before moving forward, because in many articles, in many posts, I realized that they are sharing some information related to DDD and they are defining it as a design pattern. DDD is not a design pattern. DDD is not architectural pattern. DDD is not architectural style. DDD is not a technology. DDD also is not about coding technique, okay? So before moving forward, let's try to understand the core concept of domain-driven design. When we build a solution, when we build a project, the building process is not just about coding. We have some requirements. We have business guys, project managers, business analytics, product owners. They are also main building blocks of our solution because they are providing the related information about the business, and we are developers working on the implementation side. So we are on the same ship with our business people. But unfortunately, in a classical manner, we are using different languages. Developers use completely different languages like design patterns, architectural styles, I don't know, the service layer, repository, etc., controller services, proxies, etc. And business people speak completely different language. The problem here is we are trying to reach to the same destination, but we are speaking completely different language. How it is possible to be on the same ship and with speaking different language to achieve the same goal? This is where we are applying domain-driven design. In our domain-driven design, I think one of the greatest invention from Eric Evans is ubiquitous language. This ubiquitous language, yeah, of course, we have some slides related to ubiquitous language, but this is the core for our session, so I decided to explain it a bit earlier. So in this case, we should speak the same language, because when you talk to business, you are speaking in a different language, but when you start coding, you are using completely different language. This is the biggest problem in our implementation process. So we are losing some information because business brings some information for you, and here we have translation process. We are translating, and unfortunately it is not possible to 100% translate all the information, so we are losing the value of this business sentences here. Okay, so we it means we have not 100% information, we have 50-60% precisely information. Okay, and the problem here is in the future, if you need to change something, you are using, again, two different languages. You have your own coding language. I'm talking about from the developer's perspective. You are using completely different language. You are mapping your coding to business language, okay? And after getting information, you are translating it into your code. So you have, let's say, 2 times translation process. This is the biggest problem when we develop our application. And long story short, domain-driven design, as we mentioned, is not about design patterns, design principles. It is about software development approach. DDD is a software development methodology, software development approach. DDD helps us to gain centralized business knowledge. It means when business brings some information, there is no need to translate this information to developers' language. So we are using the same language, and it means developers help business to improve, and also business help developers, the solution, to have the real language. So the business language is the same as your coding language, the same as your method, same as your classes you apply, you implement in your project level. Okay. So domain-driven design, as Vernon mentioned, it is firstly is not about technology. It is about learning, discussing, bringing business value, because you are sitting with your teammates. It is not about only developers, testers. It is all team, like business analytics, product owners. You are together discussing the business. It means now developers also know more about business, and also business team now how developers are planning to implement stuff. And it will be really easy for business people, even without learning programming language, easily understand the code, because the code reflects the business language is the same as our code language. So business people help to achieve a better design. I mean the technical implementation, like designing in C#, Java, etc. And also developers with asking proper and precise questions help to understand business well. So you are asking relevant questions to business. Of course, business also doesn't know all related the problem domain, and you are helping business people to learn more. If they learn more, it means they will reflect their knowledge to your project. So you are working together, you are using the same language, you are on the same ship and trying to achieve the same goal together. So we have zero translation between our business and developers. This is the ubiquitous language, okay? And as I mentioned, business and developer team use the same ubiquitous language. As Von Vernon mentioned, we have design. It is a code. A code is a design. This is a great definition, by the way. And domain-driven design helps us to apply the agile principles, iterative development. That's completely okay for modern days. And also, domain-driven design helps, domain-driven design brings strategic and tactical patterns to the table. So you have strategical patterns, you have tactical patterns. DDD is not just about strategical and tactical patterns. As we mentioned, DDD is foremost about learning, discussing, bringing business value, using the same language foremost, and then applying all this stuff in your strategic level for your strategic patterns, and then from the implementation perspective, apply tactical patterns. Okay, so now let's focus on our strategic patterns first. As a developer, we really don't love to apply, we really don't love to talk much. We want to code, but this is not applicable in domain-driven design, because you should participate in a business process, you should understand business process, you should ask questions, because if you don't know business well, it is not possible to reflect it to your project. This is really important. So in our strategic patterns box, we have ubiquitous language, we have bounded context, and we have context map. And they are the main building blocks of course, we also have core domain, but anyway, we'll talk about it in our bounded context section. So what is strategic pattern? So in domain-driven design, we have strategic patterns, and they are blueprints for structuring and organizing complex software systems aligned with business domain. It means you first need to understand the business, the problem space, and start to implement, move it to the solution space using bounded context. You should talk much, you should understand your core domain, you should talk to business people to understand more about business, and you should apply, you should speak in the same language, and you should try to apply the spoken language to your project. First things first, the main building block of our strategic pattern is, of course, ubiquitous language. So ubiquitous language, as Von Vernon mentioned, a shared team language. Ubiquitous language helps us to capture the concepts, terms from core business domain. So you have all the related terms, concepts, expressions, verbs, the related keywords, let's say, and you will analyze them, and you will discuss them with business people, and you will gain the exact words, and then you will be able to apply to create stuff related to these expressions and words. Okay, ubiquitous language is a language that business and developer teams use to achieve the same goal. We already talked about it when we described the ship presentation. This ubiquitous language should be developed by the team. Of course, in our strategic design, we have bounded contexts, okay? And this ubiquitous language should be applicable only inside one bounded context. We'll talk about bounded context a bit later. And ubiquitous language is about capturing the concepts, terms of specific core business domain. This is valid only inside of a bounded context. We already mentioned about it. And also it helps us to create valuable business domain models. So domain-driven design is about creating artifacts in terms of domain models. So you are designing domain models, and the first step is to understand your business and to apply, to gain the valuable ubiquitous language, to apply it to create a domain model based on ubiquitous language. Okay? And ubiquitous language serves a design. So how to capture ubiquitous language? Yeah, this is also really important. So you can use different glossaries. For example, in your domain, you may have multiple synonyms. You will definitely have multiple synonyms for the given words, let's say. And you need to discuss it with your team to select only one, and all team members should use the same term every discussion process. You can also use some drawings of your domain elements. You can draw some pictures of your business domain models. And also you can create different documentations that will help you to grab the related information from the business, to capture the information from the business. And after that, you need to talk to domain experts. The domain expert is a guy who knows about domain more than you. Let's say it can be other senior developer who works more than, I don't know, 4 or 5 years in this company, or business analytics product owners. So there is no special position like domain experts. It depends from the knowledge of the teammates. Okay? And you need to try to understand the core domain as much as possible. And then after discussing, after analyzing all this stuff, you are deciding to use, for example, these 5 terms, now, like, I don't know, let's say sheep, person, you maybe order, category, etc. So you are defining all this stuff, you are discussing, and you are selecting the proper words depending from your bounded context. This is a simple glossary. For example, we have product. So you say we have product and we have exact definition. That it should be crystal clear, as Bertrand Meyer mentioned. There should be a crystal clear definition for your words, like product, a tangible item available for purchase, order, a customer's request to purchase one or more products, the customer, inventory, shopping cart, promotion. In your glossary, you may have multiple synonyms for these elements, but at the end, you should pick only one, and you should start to use this one without it is synonym every time. Start from A to Z, from starting to the end process. Okay, now let's talk about bounded context. What is a bounded context? A bounded context is a concept from strategic pattern. Bounded context is a conceptual boundary where your domain model is valid. So you have a domain model. Let's say we all know about the models, but we will define the domain model a bit later. So we have the domain model, which it is, let's say, properties and methods. Okay, and this domain model is valid only in this context. This context defines the validity of our domain model. Okay, and this is a conceptual boundary. Bounded context is a solution space artifact. We'll also talk about it. Bounded context is a conceptual boundary where your domain model is applicable. From one well-known again, we have tactical patterns, and we are applying these tactical patterns inside our bounded context. So in domain-driven design, there is no one single solution. Okay, let's start our domain-driven design. Okay, let's create all these domain models, all these infrastructure, etc. No, you have bounded context. So it means you have a big problem. You are dividing it into smaller ones. These smaller ones is going to be your bounded context. Okay, this is like your microservice infrastructure. Okay, you have a small smaller microservices. Every microservices in this case, let's say, matches you to bounded context. So it means you have a big problem. You are dividing it into smaller ones, and they are going to be your bounded context. In your bounded context, every bounded context is an independent item. So you can apply different programming language, you can apply different technology, you can apply different architecture, and different team working on this bounded context, like in a microservice development process. Okay, so that's why domain-driven design also matches with microservice development. So we can host bounded context using different architecture. You can use hexagonal architecture, event-driven, service-oriented. I know now REST, for example, you have for bounded context, you may apply a layered architecture for one, the clean architecture for one, I don't know, the service-oriented for one, event-driven for one. So that's completely okay. You don't strict to one architecture. This is the really a good side of a bounded context. Also, the ubiquitous language also valid inside our bounded context. It means we have one-to-one relation between bounded context and ubiquitous language. You cannot use the same ubiquitous language for multiple bounded contexts. For example, if you define the ubiquitous language, it is only valid in one bounded context. For the different bounded contexts, you may use the same terms, but they are meaning completely different. For example, in one context, we have account. In another context, we have account, but they are completely different domain models because they are isolated with bounded context. So bounded context is a solution space element. We have problem space, we have solution space. If you have read different books related to domain-driven design, you realize that most of them are talking about problem space, solution space. In our problem space, we have subdomains. In our solution space, we have bounded context, because in subdomain, we are trying to grab more information about business. We are trying to understand. We are trying to learn the complexity. We are not applying anything, any architecture in our problem space, but in our solution space, we are starting to apply all these architectural styles, all these architectural patterns, technologies, etc. So bounded context is related to solution space. It is not a problem space element. Okay, the problem space element is subdomain. And bounded context is about dividing a big problem into smaller ones. Already discussed about it. And of course, bounded context is architecturally neutral. So unfortunately, our bounded context had a complex relationship with subdomains, so it is not always possible to. We are, of course, striving to have one-to-one relation between our subdomains and bounded context, but unfortunately, it is mostly not possible, because you may have one bounded context that covers multiple subdomains, or one subdomain that covers multiple bounded contexts. But in our core domain, we are trying to achieve one-to-one relationship between bounded context and subdomain. But in our generic subdomain, sometimes it is not possible. So this is a simple example of our domain. So our domain, from the enterprise architecture perspective, we have domain that divided into subdomains. And for example, in core domain here, we have one bounded context, you said so. But in our another subdomain, we have two bounded contexts. Yeah, and also the given bounded context that match to different, even three different subdomains. So it is depending from your domain complexity, from your domain, of course. And let's talk about context maps. So we have bounded contexts, okay? And what to do in this case? So you have different bounded contexts. It means, let's compare it like this. So you have, imagine like you have multiple microservices, and one microservice doesn't mean a lot if it is not interacting with other microservices. So in domain-driven design perspective, when you have a bounded context that doesn't interact with others, doesn't much value. So they should interact with each other. So context map helps us to have communication between our bounded contexts. It is really having relationship between bounded contexts. So context map is a strategic pattern, tactical patterns applied inside our given bounded context. We already talked about it. Different integrational and communication relationship between our bounded context. Let's talk about it. So we have organizational and integrational patterns, like we have partnership, we have shared kernel, we have customer-supplier relationship, we have conformist, anti-corruption, open host service, published language, separate ways, and big wall of mud. Unfortunately, we don't have enough time to talk much about all of them, but I will try to cover at least 2 or 3 of them. So we have partnership relationship. So it means you have 2 bounded contexts. They should fail together. They should succeed together. Okay, they are really dependent with each other. We have shared kernel. In most cases, shared kernel is a part of our domain. So we are having the generic codes like the related to entities, like related to our business, about value object, about domain services, domain events. We are not moving the infrastructure elements to our shared kernel. So shared kernel is about our business, the common usage for all our bounded contexts. We have a customer supplier relationship. Customer supplier means you have a producer and you have a consumer. And for example, we have big ball of mud. You can apply big ball of mud if you have already implemented the application and you want to somehow isolate it to apply domain-driven design concept, and you can wrap all this stuff into a big ball of mud and to see it as a separate bounded context. Okay. So this is a simple example. So you see let's say we have 3 bounded contexts and we have open host service here. This is a organizational and integrational communication mechanism, and we are applying published language. This is also one part of organizational integration parents here, published language. So you see we have open host service, we have published language. So we are able to write a wrapper over our open host service to have separate versions of our context map. In this case, let's say, so we have published language version 1 for this bounded context and published language version 2 for this bounded context. Great. So this is about our strategical parents. Unfortunately, it is not possible for you to bypass this strategic step to move directly to tactical ones, because if you don't have enough understanding, if you don't know what to code, what can you code? So in a simple terms. So what about tactical parents? We have a lot of tactical parents, like we have value objects, entities, we have aggregates, we have modules, we have repositories, domain services, application services, factories. They are part of our tactical patterns, and we'll try one by one cover all of them, let's say. So tactical patterns are the specific building blocks and design techniques used to implement a domain model within a bounded context. So you see, we are going to talk about in a given bounded context. So without a bounded context, you cannot apply these tactical patterns. You should first specify your bounded context. So you should first specify your ubiquitous language, and you need to have a clear solution space communication using context map. And then you can apply these tactical parents. Okay, the first tactical parent is going to be our entity. This is not entity. So we all know from the C# entity framework, we have entities. This is not the same entity. So this is a bit different. The entity is identified by its ID. In our entity is a class. I will show you a simple example here. Entity is a simple class that is not anemic model. What is anemic model? It means your class only consists from properties in terms of, let's say, C# Java fields, properties, and the related business operations, related logic methods handled by the upper layer. You have, for example, the service layer that acts as a wrapper over your entity and does the related operations to this entity. So it means, it indicates that you have anemic model. Anemic model is anti-parent, and you shouldn't apply it in your projects when you really apply domain-driven design. And when we talk about entity, we talk about a class that have, in terms of modern language, properties and methods. Every entity has its life cycle, so you can create, modify, and eventually delete it. Entities are mutable, and entities has a state that represent by its attributes, which can change over time. Okay, so Let's, before moving to value object, let's go to our project here. And first, let's, here in our Visual Studio, we have, for example, grade. So you see this grade inherits from entity base. This is our entity identified by ID. So we are defining grade. You can use it at different, even you may have your own solution for your ID. You can implement it in your database side, in your application side, the generation process. So you see, this is my grade. This is not a simple entity. In my grade, I have some properties here. And also I have behaviors. So you see, these behaviors are really related to the business. This is a domain model because this domain model really valuable from the business process. If I have the business operations related to my entity that I can push it to my grade, I'm writing it inside my grade class. For example, it has isValid, grade is assignable, it has calculate bonus method. So you see, I'm not using a separate service layer, creating a calculate bonus asynchronously, and let's call this grade somehow from the entity using the repository stuff. So I'm just going to show you the examples using C#, but it doesn't mean that it is applicable only in C#. You can apply domain-driven design in any modern language. This is a language agnostic, architectural agnostic, and this is really cool stuff to use. So we have grade here, entity base, it inherits from the entity, and this entity defines the reality of our entity. So you see, we have equality stuff here, and if we need to compare this entity with another same type entity, we should care only about its ID. If their ID are equal, it means these entities are equal. Okay, and that's about entity. About value objects, they are identified by attributes. They don't have life cycle, immutable, no state, and they should be a part of our aggregate root. And in our case, let me show you a simple example here. And in our example, we have, for example, domain range here. This is our value object. We mostly focus to move all the business processes to our value objects because value objects better than moving the business logic into our entities. Okay. So we have the short amount of time, so I will try to cover everything as simple as possible again. So we have aggregates. They are the single unit for data changes. They are associated objects treated as a single unit. Aggregates are designed to encapsulate a group of related objects, and it has a root entity, and entity can be part of an aggregate. One aggregate can contain multiple entities and value objects because your repository should interact with your entity. The entity is, let's say, a type of, the aggregate is a type of entity, but in a repository layer, in the highest layer, we are interacting with our aggregates. Okay, and you all know about the repositories. We have repository. We are providing a methods to retrieve, add, update, delete stuff, and it encapsulates underlying data storage. And we are working with aggregate roots in our repository stuff, and it defines boundary between domain and infrastructure. And for the other tactical patterns, we have domain services, application services, domain events, modules, factories, and this is our general architecture. So you see we have UI, application services, repositories, factories, domain services here. And in the core, we have entities, value objects, domain events, aggregates, which they are matter more. And for the alternative and better resources, unfortunately, I couldn't cover every aspect of the domain-driven design. We have a great book from Eric Evans, from Wim Vernon. I really love implementing domain-driven design book. And also we have learning domain-driven design book by Vlad Kononov, and also hands-on domain-driven design with .NET Core, the .NET implementation by Alexei Zemaev. Yeah, that's pretty much all about understanding domain-driven design. I hope I could explain more in a given short amount of time.